Hello, class. So today for the warm-up, we're looking at probably a little bit older on the rates for water for Crescent City or the local town. So that is. So see, we have different water usages right here, 0 to 500 CF, sewer rates, specialty districts, minimum bill amounts, and the deposits. So what does 0 to 500 CF mean for 2249? Since that's the standard rate right here. Now at the bottom, 1 cubic foot per CF is 7.48 gallons. So then we have an additional charge for things above that gallon. All right. So, question: how many gallons can we use a month without having any additional fees? So we have 7.48 gallons, and the max we can go is 500. So we multiply those two together to get 3,740 gallons of water. All right. So today we're going to be working with inequalities, one variable. No graphing today. That'll be in the next class. And interpret solutions. Identify equalities, true or false, based on number of solutions. All right. So we have the warm-up vocab, have the gist, review how they differ. They look different but the same operation. A second example, number of solutions, and then a checkpoint, followed by the classwork, which will be a handout. So should we just review vocabulary, equivalent, inequalities, properties of inequality, and solution to inequality. All of this should be old news, but it's okay if it's not. So the gist of what's going on, I'll put that right over here for right now. So a multi-step equation and a multi-step inequality. Notice that we have 3x plus 4 is equal to 19, and this one we have 3x plus 4 is strictly greater than 19. So this we're going to compare and contrast these. All right. So a number of solutions for each of them. We have one solution for the multi-step, or infinitely many solutions for the inequality. Ways to show a solution. We have x equals 5. Once we go ahead and push through all this, it will find that x is equal to 5. Or we'll find that x is strictly greater than 5. And you can think of infinitely many numbers bigger than 5. And the symbol always remains equal. Reverses when multiplied or divided by a negative. We'll see this come in play in a little bit. All right. So this is just like the gist of what's going on the surface. Multi-step equations, one answer. It's always something equal to something else and always remains equal. Multi-step inequality, infinitely many solutions. It's displayed as x is greater than 5, x is less than 5, greater or less than 5, greater or equal to 5. 5 is just an arbitrary number in this case. But the main thing is reverse when multiplied or divided by a negative number. We have to keep this in mind. All right. So let's continue on. This is a review. What does that symbol mean? What it says is less than or equal to. That or equal to is actually quite important to remember. Next we have what I call it's greater than, but I call it strictly greater than. That way we make sure that it has to be bigger than that. We have the greater than or equal to. And then we have the strictly less than. All right. So that little line adds the or equal to. Without it, it's strictly greater or less than. Okay. Review 2. What's the following true statement? Is 3 bigger than 5? Is 3 strictly greater than 5? Well, you should be saying that's not necessarily true, so that's false. What about 4 is strictly less than 7? Well, you can say that's true, because it is. 3 is less than or equal to 3. Notice I said or equal to. That part's true, so we're going to say true for that and see why about that in a minute. And then we have 2 is greater than or equal to 3, which again is false. All right, let us continue. How do they differ? We have 3 is strictly less than 3, and 3 is less than or equal to 3. So if we look at it, we have 3 is less than 3, or 3 is less than 3, or 3 is equal to 3. first one we can definitely say is false on both of them. But this term or makes this one true. Because think about this. You could go to Burger King, McDonald's, or Taco Bell for lunch. If you had lunch at one of those places, you didn't have to go to all of them. You still had lunch that day. It's an or statement. All right? So that's this kind of way to think about or in math is as long as one of them is true, if you have an or statement, then they're all true. Then you're going to say, hey, this is a true statement. As long as one of them is true with an or statement, it is true. But if they're all false, then it's false. But all you need in an or statement is one to be true. All right? So that or makes it true. So as you see, false, but this is true. Do 3 is greater, less than, or equal to. So, may look different, but we're still using the same operations we've been using in the past. So we have 3x minus 10 is equal to 2. So simple swap, all right? So what we're going to do is just swap it with a different one of the symbols, in this case less than 2, and go through to figure out what we need to do. Well, we want to isolate x, but right now we're multiplying by 3, and we're subtracting 10. So what we need to do is add 10 to both sides. Because right now, 10 is not divisible by 3, 2 is not divisible by 3, and if we try to divide by 3, we're going to have a fraction. Not a lot of people like those. So we're going to add that 10 to both sides. When we do that, we can simply say that's gone, leaving us with 3 is strictly less than 12. Now that we divide both sides by a positive 3, we don't have to flip the sign, but it becomes canceled on one side, reducing on the other, x is strictly less than 4. Done. All right. So a second example, but just a slightly bit harder, because if you notice, we have an x on both sides, but we have that 3 and 5, negative 5. So you should always look at your variable and just say, like, do I want to deal with the negative 1? If I want to deal with the negative 1, kick the 4 over. But if you'd rather not, kick the 2 over. I'd rather not, so I'm going to kick that 2 over. So I'm going to subtract that 2 from both sides. That cancels over here, leaving us with 3x, and 4 minus 2 gives us that 2x. Or 3 is strictly less than 2x minus 5. Now, we want to kick the 5 over because we're going to go back into the same operations we had in the last slide. We want to get the x by itself, so we need to realize that we're multiplying by 2, subtracting 5. So we need to do the opposites of those. Divide by 2 and add 5. So let's go ahead and add that 5 first, because 3 and 5 are odd and not divisible by 2. And if you add any two odd numbers together, you're always going to get an even. So that's why we always want to do that. So, and I can go in a little bit detail about why that is if you actually have a question about that. Anyways, 5 plus 3 gives us an 8. 2 is now strictly larger than 8. 2x is strictly larger than 8, that is. So now we need to divide by that 2. So, divide by the 2. We see that we're going to cancel over here. 8 divided by 2 will give us a 4. We'll see the cancellation and reduction. So 4 is strictly less than x, or you can say x is strictly greater than 4. All right. So negative experience. So this is where we are going to have to flip it. We're going to see this one twice, leaving the x alone and moving the x, and how we're going to get the same exact answer, as long as we remember to flip the sign for divide by negative. So first we're going to leave the x alone and just kick over the 1, and then divide by negative 1, or multiply by negative 1. So we're going to add the 1 to both sides, giving us a negative x is less than or equal to 10. But now we need to multiply by negative 1 to clear out that negative symbol on the x. So when we do that, what we're actually doing is distributing a negative 1. And when we take care of that, we also need to flip that sign. So x is now greater or equal to negative 10. So that's what happens when we multiply or divide. We have to flip that sign. Must flip the sign when we divide a negative value, as stated on an earlier slide, but this is just a reminder. We'll see why. So we're going to move the x instead. As you see, it's the same exact answer. In the previous slide, we got x is greater than or equal to negative 10. So let's go ahead and move the x instead. So we're going to add x to both sides. Even though it says negative 1 is less than or equal to 9 plus x. Now we're going to subtract 9 from both sides. Notice when we get negative 10 is less than or equal to x. Notice this is the same exact answer. This side, as I was told as a kid, the alligator is facing the x because the x is bigger, and this one is still facing the x. So x is larger than negative 10 in both answers, so it's the same answer. That is why we need to flip the sign. All right? All right. Let's keep on going. Number of solutions. So we've seen this in the past where we have the case method. Case 1, there's only one potential solution for the old style, but this one there's infinite solution, but there's only one way to write it kind of thing. Flip it around, flop it around. But there's also the identity or no solution. There's 2 solution types or 1 solution type kind of thing. All right. So let's go ahead and work through this a little bit. So the first things first is you should see that we need to distribute that 3 and that 2 because that 3 does not divide anything, 2 doesn't divide 3, so we might want to distribute everything. So we're going to distribute that 3, then we're going to distribute the 2. So we see that 3 times x, 3 times negative 2, plus 1, plus, then it's going to be x plus 2x plus that. Multiplying out, 3 times x gives us 3x, 3 times negative 2 gets us negative 6, and we're going to add 1 to it. X, 2, that's just doing one side, so we're going to do the other side at this point. As we simplify over here, sorry. So subtract that, now we're going to start working on this side. So we're going to multiply those out and continue on. Now, you see that we have a 3x and a 3x on both sides. And what does that tell us? We're in case 2. So now we need to inspect our secondary area. Is negative 5 greater or equal to 4? No. Case 2, greater 5, greater or equal to positive 4? False. So we have no solution. So that's how you can tell it has a solution. Instead of having an equal sign, you check that inequality. Does that inequality make a true or false statement? If it makes a true statement, you have a solution. If it makes a false statement, it makes no solution. So true, infinite solutions. False, no solutions. All right. So here's the checkpoint for you. Give it a pause. Give it a go. Yes, there's mixed fractions, so you will have to take care of that. Welcome back. So we have negative 4 thirds, 1 1/2, and 1/4. So let's go ahead and mix that fraction. Make things a little easier. And we're going to be looking at the fact that we have those numbers. So what's the lowest common multiple of those? Just as a refresher for this, since this still seems to be a bit of an issue for people. 2, 3, and 4. Well, we can see that 12 is going to be the smallest number because 4 and 2 are divisible. 4 is divisible by 2, so we need to really worry about that 4 and 3. 4, 8, 12. 8 is not divisible by 3, but it's divisible by 2. 12 is divisible by both 3 and 2. So let's just multiply everything by 12. To do that, distribute that 12. All right? So now we can start reducing. We're left with a 4 there, 6 there, and 12 divided by 4 gives us a 3. So let's just pull all those up. 4 times 4, negative 4 gives us negative 16. 6 times 3, 6, 12, 18. And then 3 times 1 gives us 3. Okay. So now we need to simplify the one side. 2x is less than or equal to 3. We're going to end up with a fraction here because you can see that 3 is odd value. That is x is less than or equal to 3/2. So it's just a way to go about it, a way to look at it. Sometimes we get fractions as answers, and that's perfectly fine. All right? So let's continue on. As you see, it was going to be a handout, but actually give you guys a handout instead.